All right, on to 5.3, part 3 of the videos. Example 3 says to evaluate as calculator free as possible. So we're going to try and do A through D without using a calculator. And the strategy we're going to use is somewhat similar to something we looked at last time. Last time we looked at some problems where we solved exponential equations by getting a common base on both sides. And we took numbers and broke them down into smaller bases. We're going to use a similar strategy here. So if you look already at A through D, all these bases, 27, 8, 16, and 9, they all look, I hope they all look to you as numbers that you could rewrite using a smaller base. And so what we're going to try and do is come up with a final answer without an exponent and try to do this as calculator free as possible. So let's look at A. When you see 27, I hope that you're kind of thinking to yourself that you could rewrite that 27 using a smaller base. And 27 is a number that's come up enough that I hope we realize how we could rewrite it. So if we think to ourselves, we hopefully realize that 27 is just a power of 3. 27 is the same thing as 3 to the third power. So I'm just going to substitute the 27 for 3 to the third. And then on the 3 to the third, the 27 was also raised to the 2/3 power. So at this point, what we can go ahead and do is take these exponents and multiply them together. That's just the power of a power rule. If we have a power raised to another power, we can multiply those powers together. And if we multiply 3 times 2/3, that's like a 3 over 1 times 2/3. 3 times 2 is 6. 1 times 3 is 3. And then 6 divided by 3 is just 2. So what we have here is 3 squared. And you might have done that in your head, knowing that 3 times 2/3 would ultimately give you an answer up here of 2. At this point, now we can do this in our head. 3 squared is just 3 times 3, and it's 9. So we've taken something that looked pretty complicated, 27 to the 2/3, something kind of puzzling, and just rewritten using a smaller base, used our properties of exponents, and then we've been able to come up with a pretty simple looking answer. Let's look at B. So the number 8, we want to think about how we could rewrite that using a smaller base. And if something doesn't come to mind right away, what you could do is just start trying bases. Okay, if we take 1 and raise it to the first power, it's just 1. If we take 1 and raise it to the second power, it's just 1. 1's pretty boring. If we raise it to most numbers, we just get 1 as a result. So let's move on to the next integer. We move on to 2. If we take 2 and square it, 2 squared is 4. And then 2 to the third power is 8. So there we go. That's how we can rewrite the 8. 8 is the same thing as 2 to the third. So we'll replace the 8 with 2 to the third. And that whole base, 2 to the third, is raised to the 5/3 power. So we'll take a look here. We just have to multiply these fractions together. Rather than write out all the work, we might notice here that multiplying by 3 and this division by 3 will cancel. And all that's left over is 2 to the 5th power. You could think of this 3 as 3 over 1 and multiply the fractions, and you'll end up with 15 over 3, which divides to give us an exponent there of 5. 2 to the 5th power, we can do that in our head. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So again, we've taken something kind of mysterious looking, 8 to the 5/3, and translated it into a much nicer answer of 32. I'm going to give you some time to look at C and D and see if you can make some sense out of those. And then I'll explain to you the correct answers.